The observable universe refers to the portion of the universe that we can observe and study using telescopes and other instruments. However, this capability is limited because light, the main source of information about the universe, can only travel at a finite speed. As a result, we can only observe objects or events that are within a certain distance from us. We cannot directly see objects or events that occurred long ago beyond this limit. The diameter of the observable universe is estimated to be approximately 93 billion light-years, which is much larger than the estimated age of the universe, about 13.8 billion years. This discrepancy arises because the expansion of the universe has caused objects that were once close together to move away from each other, and the light from those objects has taken more time to reach us. Overall, the observable universe is a vast and fascinating space, but there is still much we do not know about it. However, through the use of telescopes such as NASA's James Webb Space Telescope and other scientific instruments, we continue to learn more about the structure, composition, and history of the universe, as well as its various phenomena. To reach the farthest limits, we would need to develop transportation methods capable of transcending space-time, such as distortion engines or wormholes. These concepts have long been debated among scientists. Some believe they are impossible or contradict the idea of faster-than-light travel. Even if such travel were theoretically possible, it would require technological advances and machinery currently beyond our capabilities. The theory of cosmic inflation posits that the total size of the universe is at least 10^2^3 times larger than the observable universe, a number so vast it is incomprehensible to the human mind. Since we cannot see or measure the unobservable parts, we have no way of knowing with certainty what lies beyond its limits. Nevertheless, we can develop theories based on the information gathered from distant galaxies. NASA, in collaboration with other space agencies and research institutions worldwide, has made numerous significant contributions to our understanding of the universe. Even before the James Webb Space Telescope became operational, NASA had already released Hubble's ultra-deep field images. When the James Webb Telescope made its debut, it was tasked with observing the most distant galaxy ever recorded. These images revealed numerous galaxies shining in the distant cosmos, appearing as they did millions of years after the Big Bang, approximately 13.8 billion years ago. The expansion of the cosmos stretches light to redder wavelengths, allowing the James Webb Space Telescope to detect infrared light. This capability has enabled scientists to observe galaxies forming during the early stages of the universe's history. The telescope has also observed several fields of distant galaxies, helping scientists study star formation rates in the early universe. These data revealed a significant population of galaxies actively forming stars in the universe's infancy. For centuries, humans have pondered whether we are alone in the vast universe. These discoveries suggest there may be millions of galaxies in the unobservable regions of the cosmos. The idea is both shocking and awe-inspiring. The likelihood of life beyond Earth has never been more compelling. Many planets outside our solar system have been discovered using techniques like the transit method and radial velocity. Some share similarities with Earth and could harbor life. This theory gained more weight thanks to the James Webb Telescope's observations of exoplanet WASP 96b, whose light spectrum revealed the presence of water molecules, as well as hints of haze and clouds, conditions not previously associated with habitable planets. Given these findings, it is difficult to rule out the possibility of alien life. While no conclusive proof exists yet, the evidence makes the existence of extraterrestrial life a tantalizing possibility. The concept of the multiverse, also known as the many-worlds interpretation, is a theoretical idea in physics and philosophy suggesting the existence of multiple parallel universes or dimensions beyond our own. In quantum physics, some interpretations propose that the act of observation causes a system to split into multiple states, each representing a different outcome. The multiverse remains speculative and unsupported by conclusive evidence. While some scientists find the idea intriguing, others remain skeptical. The possibility of the multiverse is as uncertain as Schrödinger's cat or the true nature of dark matter fascinating, but in need of more research. Another intriguing concept is dark flow, first proposed in 2008 to explain why some galaxy clusters appear to move faster than expected. Dark flow suggests these clusters might be influenced by some form of dark matter or energy pulling them in a specific direction. However, the evidence is controversial. Some studies support it, while others attribute the observations to measurement errors or other factors. The limit of the observable universe is defined by the cosmic light horizon, the maximum distance from which light has had time to reach us since the Big Bang. This is not a physical boundary of the universe itself, but rather the edge of what we can observe. Beyond it, the universe may continue infinitely or curve back on itself, depending on its overall geometry. The cosmic microwave background, CMB, a faint glow left over from the Big Bang, marks the farthest point back in time we can observe with electromagnetic radiation. It provides a snapshot of the universe when it was only 380,000 years old and remains a cornerstone of Big Bang evidence. If humanity overcomes immense technological challenges, we may attempt interstellar travel. Concepts such as fusion propulsion, antimatter drives, and the Breakthrough Starshot initiative, which aims to send tiny spacecraft to nearby stars using laser-propelled light sails, are early seeds of this dream. Even more speculative are warp drives and Einstein-Rosen bridges, wormholes, still in the realm of theoretical physics. While these remain science fiction for now, they reflect our enduring desire to reach beyond the stars and find our place in the universe. Our understanding of the observable universe is constantly evolving as new discoveries reshape our perception of reality. The James Webb Space Telescope, along with upcoming missions like NASA's Nancy Grace Roman Space Telescope and the European Space Agency's Euclid mission, will continue to refine our measurements of cosmic distances, galaxy formation, and dark matter distribution. These tools promise to bring us closer to answering some of the deepest questions in cosmology. The sheer size and age of the observable universe present a humbling perspective on our place within it. Every point of light we see in the night sky is part of an unfathomably vast cosmic web, galaxies connected by invisible filaments of dark matter, stretching across billions of light-years. And yet, all of it is merely a small fraction of the total universe, most of which lies beyond our current observational reach. Some scientists speculate that the unseen parts of the universe may hold exotic forms of matter, entirely different laws of physics, or even regions where time flows differently. If the multiverse exists, then the laws of nature we experience might be just one of countless variations, and somewhere in another universe life could have taken entirely unfamiliar forms. From ancient stargazers mapping constellations to modern astronomers peering through the most advanced telescopes ever built, humanity has always sought to push the boundaries of knowledge. The questions we now face about the shape of the universe, the existence of other worlds, and the possibility of life beyond Earth are the latest chapter in this timeless quest. One day, future civilizations may overcome the speed of light barrier or harness cosmic phenomena like wormholes to travel beyond the observable horizon. If that day comes, our descendants will explore realms that today exist only in theory, places where no human mind has yet wandered.